Good day, sir. I am Nicolzam G. De Los Reyes from BSEA 2B. I am here recording this video to discuss to you what I have learned in Module 1. So here is my video presentation. As you can see in this video, you can see a series circuit and a parallel circuit diagram. To determine whether it is a series circuit or a parallel circuit, you must first analyze the diagram. In series circuit, you can see that the flow of electricity is in single path, while in the parallel circuit, you can see that the flow of electricity is in multiple paths. In series circuit, in getting the total resistance, it is equals to R1 plus R2 plus R3, so on and so far. And getting the total voltage, it is equals to V1 plus V2 plus V3, so on and so far. And getting the total current, it is all equal. Current 1 is equals to current 2 is equals to current 3, so on and so far. Also, we can use the Ohm's law in getting the voltage in each resistor. V1, which is voltage 1, is equals to current total times R1. V2 is equals to current total times the resistor 2. V3 is equals to current total times the third resistance. Now, in a parallel circuit, in getting the total resistance, it is equals to 1 over R1 plus 1 over R2 plus 1 over R3, so on and so far. Next, in getting the voltage, total voltage in parallel circuit, the total voltage is equals to V1, voltage 1 is equals to voltage 2 is equals to voltage 3. And in getting the current total in parallel circuit, it is equals to current 1 plus current 2 plus current 3, so on and so far. Also, we can use also the Ohm's law, but in different ways in getting the current in each resistors. I1 is equals to V total over R1. Second current, or I2, is equals to voltage total over R2. Current I3 is equals to voltage total over resistor 3 or RT. In series circuit, if you add resistor, the resistance will rises up and the current will lower down. While in a parallel circuit, it is inversely proportional, because if you add resistor, the resistance will lower down and the current will rises up. In a series circuit, there are 9 volts, 6 ohms, 1 ohms, 7 ohms, and 3 ohms. In this problem, number 1, they are looking for the total resistance. So in finding the total resistance in a parallel circuit, we must use the formula of RT is equals to R1 plus R2 plus R3 plus R4. So since it has 4 resistance, so let's RT is equals to 6, which is the resistor 1, plus 1, the resistor 2, plus 7, the resistor 3, plus 3, the resistor 4 is equals to 17 ohms. So the total resistance in a series circuit is 17 ohms. Now let's proceed to question number 2. Find the current total. So in finding the current total in a series circuit, you must use the formula of current total is equals to voltage total over resistance total. So the voltage total is 9 volts all over the total resistance is 17 ohms equals, now you get 0.53 amperes. The current total in a series circuit problem is equals to 0.53 amperes. Proceed to number 3 question. So find the voltage drop across each resistor. So as what I said, we must use the formula of the voltage in each resistor in a series circuit. V1 is equals to I total times the resistor 1. So I total is equals to 0.53 times the resistor 1, which is 6 ohms, resistor 1 6 ohms, times 6 ohms, now you get the answer of 3.18 volts. So in voltage 1, the voltage drop across each resistor is equals to 3.18 volts. Now let's compute the voltage 2 through resistor 2. 0.53, the voltage, the current total, times resistor 2, which is 1, times 1, equals 0.53 volts. So in voltage 2, in voltage 2, the voltage drop across resistor 2 is equals to 0.53 volts. So voltage 3 is equals to current total times the resistor 3. So 0.53 times 7, the 7 ohms, the value of resistor 3. So it is equals to 3.71 volt. So in voltage 3, the voltage drop across each resistor which is resistor 3, is equals to 3.71 volts. Now, let's now compute to the voltage for voltage 4 is equals to IT, which is 0.53, times the value of resistor 4 is equals to 3 times 3 is equals to 1.59 volt. So the voltage voltage drop across resistor 4 is equal to 1.59 volt. So to check whether your answer here is correct, you must add all the voltage and compare to your total voltage, since it is the voltage in each resistor. So let's check. 3.18 plus 0.53 plus 3.71 plus 1.59 is equals to 9.01. So we have the same 9 volts. That's all for problem in series circuit. In a parallel circuit, there are 24 volts, 12 ohms, 16 ohms, and 8 ohms. Now, we will now solve problem number 1. Find the resistance total, or the total resistance. So, the formula in getting the total resistance in a parallel circuit is equals to 1 all over 1 over R1 plus 1 over R2 plus 1 over RT. So 1 all over 1 over 12 plus 1 over 16, 1 over 1 over 12 plus 1 over 16 plus 1 over 8. Since R1 is equals to 12 volts, R2 is equals to 16 ohms, R1 is equals to 12 ohms plus 1, the R2 is equals to 16 ohms, then RT is equals to 8 ohms. Now let's solve in a calculator. Now you will get the total resistance in a parallel circuit problem is equals to 3.69 ohms. Now let's go to problem number 2. Find the current total. So, in getting the current total in a parallel circuit, you must use this formula. Current total is equals to voltage total over resistance total. So, voltage total is equals to 24 volts over the total resistance, which is 3.69 equals, now you get the current total of 6.5 amperes. So 6.5 amperes here, 6.5 amperes. Now let's go to problem number 3. Find the current through a voltage drop across each resistor. So in getting also the current through each resistor, you must use this formula. I1 is equals to voltage total over R1. Let's solve for this one. So voltage total is equals to 24 over 12 is equals to 2 amperes. So the first current through each resistor has an 2 amperes. So 2 amperes. 2 amperes. Let's go to second current. VT, second current is equals to VT over R2. So voltage total is equals to 24 over the value of R2 is equal to 16 ohms. So let's put it in already. Equals 1.5 amperes. So the second current through each resistor 2 is equals to 1.5 amperes. 1.5 amperes. Now let's go to third current. So I3, or the third current, is equals to voltage total over resistor 3, or the third resistor. So the voltage total is equals to 24 volts over the value of R3 is 8 ohms equals 3 amperes. So the third current through resistor 3 is equal to 3 amperes. So 3 amperes. Now let's go and find the voltage drop across each resistor. Since in parallel circuit, the voltage total is equal to all the voltage. So voltage total is equals to V1 is equals to V2 is equals to V3. Now therefore the total voltage across each resistor is equals to the total voltage, which is 24 volts.